Hello everyone, and welcome back to my MATLAB programming tutorial series. In this lesson, we'll explore one of the most important structures in programming, the for loop. A for loop allows your program to repeat actions automatically. For example, counting numbers, performing calculations, or generating a sequence, without you needing to write the same line multiple times. We'll look at 3 examples today. 1. Counting numbers from 1 to 5. 2. Printing the terms of a geometric sequence. And 3. Calculating a factorial using a loop. By the end of this video, you'll understand exactly how for loops work and where to use them. Let's begin.
Let's start with a very simple example to see what a for loop looks like in MATLAB. As always, comments start with a % and help explain the code. % for loop basic example. This script counts from 1 to 5 and displays each number.
Now here's our for loop. For I equals 1, 5. Disp I. End. This means start a variable I at 1, then increase it by 1 each time, and stop when I reaches 5. Each time, MATLAB runs the line inside the loop. Here, disp I, which displays the current value of I. Every for loop must end with the word end, which tells MATLAB where the loop stops. When we run it, we get 1, 2, 3, 4, 5. And that's it, our first automatic repetition in MATLAB. Now that we know the structure, let's use it for something more interesting. In this example, we'll print the first n terms of a geometric sequence. A geometric sequence is a series where each term is obtained by multiplying the previous one by a constant number, the common ratio. Let's say we start with 2 and multiply by 3 each time. 2, 6, 18, 54, 162, and so on. We can easily create that using a for loop. We ask the user for the first term, the ratio, and how many terms to display. First term equals input, quote, enter the first term, colon, space, end quote. Ratio equals input, quote, enter the common ratio, colon, space, end quote. N equals input, quote, enter the number of terms, colon, space, end quote. In MATLAB, the input function is special. It both displays a message on the screen and waits for the user to type a value, all in one line. That might feel a bit unusual if you've used other programming languages like C++ or Python. For example, in C++, you would normally write something like cout, quote, enter a number, quote, cin, n. That's 2 separate commands, one to display text and another to read input. But in MATLAB, the function input combines both steps. The text inside the quotes, enter the first term, is what the user sees, and MATLAB automatically waits for a value to be entered. Whatever number the user types, for example, 2, 3, or 10, is stored directly into the variable you specify. So, after this code runs, first term equals input enter the first term, If the user types 2, the variable first term will hold the value 2. The same logic applies to the next two lines. Ratio stores the common ratio, and n stores how many terms we want to display. Then we start with term equals first term to display the first term in the first loop repetition. For I equals 1 colon n, disp, square bracket, quote, term, space, end quote, num2 string, round bracket I, round bracket, quote, colon, space, end quote, num2 string, round bracket, term, square bracket, semicolon. Term equals term, star, ratio, semicolon. End. The variable I goes from 1 to n. Each time, MATLAB displays the current term. Then it multiplies the term by the ratio, preparing it for the next iteration. Now, you might be wondering, what does num2string mean? That's short for the MATLAB function num2string, which converts a number into text. When we use num2string of I, MATLAB takes the numeric value of I, like 1, 2, or 3, and turns it into a string so it can be combined with other words in the display command. Without num2string, MATLAB wouldn't know how to print numbers together with text. So, num2string simply bridges the gap between numeric values and character text in MATLAB. Let's test it. If we enter first term equals 2, ratio equals 3, and n equals 5, we get term 1 equals 2, term 2 equals 6, term 3 equals 18, term 4 equals 54, term 5 equals 162. Perfect. Our for loop generates the entire geometric sequence automatically. Notice that at the end of the loop, the value of the term variable is 162 multiplied by the ratio. Now let's look at one more practical use of a for loop, calculating the factorial of a number. You might remember that the factorial of a positive integer n is the product of all whole numbers from 1 up to n. For example, 5 factorial, written as 5 exclamation mark, equals 1 times 2 times 3 times 4 times 5, which equals 120. We can easily compute this in MATLAB using a for loop. Here's our script. %for loop, factorial calculator. This script calculates the factorial of a number entered by the user. We start by asking the user for the number. N equals input, round bracket, quote, enter a positive integer, colon, end quote, round bracket, semicolon. Before the loop begins, we set the result variable to 1. Result equals 1, semicolon. Now, the loop multiplies the result by every number from 1 up to n. For I equals 1 to n, result equals result multiplied by I. End. After the loop finishes, we display the result. Disp, round bracket, square bracket, quote, factorial of, end quote, num2 string of n, quote, is, end quote, num2 string of result, square bracket, round bracket, semicolon. Let's try it out with n equals 5. The program prints, factorial of 5 is 120. It works perfectly. You can test other values. For example, n equals 3 gives 6, n equals 7 gives 5040, and so on. This is a classic use of loops, performing a repeated calculation step by step. Let's summarize what we learned today. The for loop is used to repeat actions a fixed number of times. It has a clear structure. For variable equals start to stop, actions inside the loop, and the word end. Inside the loop, you can display results, update variables, or perform calculations. Loops make your code shorter, cleaner, and more flexible. In this video, we counted numbers from 1 to 5, printed terms of a geometric sequence, and calculated a factorial. Each of these examples used the same structure, only the action inside the loop changed. If you found this tutorial helpful, don't forget to like, subscribe, and after the subscription, hit the notification bell so you don't miss the next MATLAB programming lesson. Thanks for watching, and see you in the next one.